So we will just do a quick recap of what we did yesterday. Before that, we will just go back, do a 5-minute revisit on what we are going to cover. This is for the sake of people who did not attend the class yesterday, and because the recording was not available. So therefore, we are recapping for the benefit of them. So myself, I'm Arun, 17 years of experience in IT. If you consider from 2002, it is 22 years of experience in both the front end, middle end, and the back end. So front end is basically .NET and languages, and back end is SQL Server. And I have dealt with SQL Server both the OLTP system, which we are going to see, and the OLAP system. So analysis part and also the data insert, update, delete, where the transactions happen, the transactions and the analysis both. So from Microsoft perspective, the Microsoft tools are used. So therefore, I am from the Microsoft background. So the tools that I have been using for this purpose is SQL Server. So development in SQL Server, how do we do? Analysis in terms of analyzing the data, then moving the data from one system to another system, making changes, which is called ETL or extract, transform, load. And then finally, also the reporting part. So this is my area. I have done consulting and training for these in these areas. Now let's go through the course coverage. This course coverage is called Basic SQL Server. So we'll be covering only the basics. The entry profile is people who are completely new to SQL Server, who want to learn SQL Server to change their career path. So they may not be from the IT background, but they want to get into IT background. Some of them, they want to switch to data science because that is the happening thing, if you say. And data is very important always, whether it is AI or whether it is IT, data is important. So they want to switch to data. These are the candidates for this course. Then basic SQL knowledge of tools like Excel which store data is good to have. But even if it is not there, that is fine. The course duration is 22 hours. The timing will be 8:30 to 9:30. And the topics yesterday we have seen, the first topic will be the logical architecture of SQL Server. Then we will see how to design tables. Then we will see the language basic, which is used to program SQL Server. And we will see certain DML statements. DML statement in the sense, statements of insert, update, and delete. So then after that, we will see once you have put the data into SQL, how are we going to query the data? So we have divided it into 3 levels, basic, joins, and subqueries. So by the end of the 3 topics, you will come to know the data that has got into SQL Server. How do I retrieve the data using different kinds of queries? Then we will look at other features given by any database engine. So here specific to SQL Server, things like stored procedure, cursor, and functions. Stored procedure is used for implementing certain processes, database processes, like inserting into a table, updating a table. There are many things that need to be done when I say I have to do one function, like withdrawing cash, example. So that is shown in stored procedures. During that process, how do I access the data? So for accessing the data, you have an option called cursor, feature called cursor. We'll see that. And functions for implementing complex calculations and logic, we use functions. We'll look at them. Then we will also look at triggers and views. So triggers and views, when you're implementing your table, so it's called table design, you will see that I have to specify constraints, what kind of data type has to be used in the table. Then how do I identify uniquely one row? So that is done through data types, keys, and then rules, business rules using check constraint. So this is the basic business rule. For implementing certain advanced business rules, you have triggers. And finally, we will be looking at views. So views are a method to look into the SQL Server data without getting or getting exposed to the entire data. So the complete data will not be visible to you. Only some part of the data that is intended for the user will be visible through views. So views is a mechanism to implement data security. So this is the quick recap of the coverage, which we have already done. Now, let me share the recap of what we have done or we have seen yesterday completely. So first part, we have seen that in any business, there are two main database systems. The first database system is called OLTP, where transactions are mainly the objective. So objective is what? Suppose I am doing a business, whatever business I am doing, the data has to be entered into the system. So that is the main intention of the OLTP system. Then what is the OLAP system? After you have entered the data, then I have to do some complex analysis. So the business people who are into business knows. So we do the complex analysis. And why do we analyze? So that reports can be given, and based on the report, decisions can be taken. Now, the OLTP and OLAP systems being the two main database systems in any business, they're different in nature. Why? Because the intention is different. So here the intention is capturing the transaction. Here the intention is analyzing the transaction data that has been captured. So there will be difference in nature. We have seen that yesterday in detail. So with respect to data types, they will be different. How they are, how the tables are created in terms of relations, that would be different. Table creation will be there, but how they are related to each other, that will be different. How they are modeled, that will be different. Like the ER modeling is used for OLTP system. For OLAP system, we have dimension modeling. So the purpose is different. Therefore, certain things would be different between them. And any database system or any database engine can be used for implementing both the systems. So OLTP system also, I can use a database engine. Same database engine is used for OLAP system. So here we are going to be looking at SQL Server as that database engine, a tool which is used to store, to maintain, and finally, if the data has to be deleted, delete it. So whatever needs to be done with the data in terms of putting the data into the system, getting the data out of the system, or for all of that, we are going to see SQL Server. So SQL Server will be seen for implementing the OLTP system. This is what we are going to look at. So this is what we have seen yesterday. Then we saw the process. When we are implementing an OLTP system, there is a process that we have to go from requirement to implementation. So I have to collect requirements, using the requirement model, then design, then implement. So we have seen the entire process. So that flow is from requirement to implementation. And what is the process? So we have first the high level design, where you decide where the data will be. Will it be in every branch? Suppose I am talking about an industry or a business like Reliance Fresh. Will the data be present in every branch, or will it be present in the main office where the data will be present, etc.? These are decisions that are taken in high level design. Should the data be present in detailed format, or should it be summarized? That means at the level of the region, I will get data which is going to be for every day. And at state level, I may want the data for monthly. So consolidated data. So should it be consolidated? How frequently should I consolidate? Okay, if the data is consolidated, how do I get the data? Suppose I have one branch in Leh Ladakh kind of region, okay, or Kashmir, but there still the lines, the internet connectivity, etc., is not that great. Then how do I send the information? Should it be online? How do I send it online? So these are the high level decisions that they are taken during the high level design phase. Then modeling phase. Then you come to a little lower level. Now you have to decide how you are going to store the data. So in modeling phase, which we are going to see in the recap, we will see how to create data containers called entity, etc. That is what is the modeling phase. Then you have the low level design. So where you decide whether I have to normalize the data, remove the duplicate, or introduce the duplicate. So that is called low level design. And then finally you go to implementation. Implementation means, okay, I have now a set of tables with me in the paper. I have to now use a tool to create the tables, etc. So which tool should I use? That is where we are going to be using SQL Server. So you have to understand what is the purpose of SQL Server as a database engine. That is why I covered all this yesterday. So once we come to low-level design talks about normalization and denormalization. So I wanted to just show an example. I'll show a quick example of normalization, denormalization. Once I come to have entities, one more aspect I wanted to also talk about is entity relationship diagram. So let me just share that piece again with you. When you're talking about modeling, we use entity relationship diagram. So we first find out in the business, what are those containers or what are those objects in the business which will have certain piece of information, like the branch, like the product, like the customer, like the employee. So we first identify. How do we identify? The business will give you the requirement. So from the requirement, you will identify the entities. These containers are called entities. They can be physical, they can be logical. Like for example, if I look at check is a physical entity. Branch is a branch is a physical entity. If I look at a banking system, I'm giving an example of banking system. Then what about transaction? It is a logical entity. What about account? Account is a logical entity. You can't physically see the account. It is created logically and the information is stored. Who is the account holder, etc., etc. What is the balance of the account? So this is what is decided in entities relationship model. In that, entities is decided, and then attributes. Attributes means for each entity, each object, what are those headings under which the data is stored. That is what is called attribute. We can call it as property or attribute. For example, account means account ID has to be stored. Account holder name has to be stored. Balance has to be stored. So these are all called attributes. Then you go to relationship. So between two entities, two objects in the business, data objects. They are called data objects because they'll contain the data. What is the relationship? How is check related to account? How is account related to customer? How is customer related to or account related to branch? So these questions have to be answered. So they are answered through relationships. We can have many kinds of relations. One-to-one means the relationship between the two objects is one-to-one. Like one branch, one manager. One manager can be manager of only one branch. So one-to-one relationship is there. Then one-to-many. One-to-many means one customer can have many accounts. That's an example of one-to-many. Then many-to-many is also there. So many-to-many means what? One customer can have many accounts. One account can have many customers. We have joint account holders, right? So joint accounts are there. So that is there. So many-to-many relationships. So this is the main aspect of modeling. One more aspect of modeling is once you have modeled, this is the logical paper pencil thing. So it will be all in paper pencil. Just wanted to quickly show an image. At the end of this, what will you see? Though this is not part of the training, I just wanted to show the diagram. So let me just show this diagram. I will share this picture or screen with you. Just give me a minute. So I have this is how an entity relationship diagram will look. We won't get into details because that is not our concern. But what is it going to do that we have to understand? It is going to capture the details of the business in terms of what are those, logical objects or entities which are going to be containing the data. Then what attributes are there? You can see the attributes. This is called as the diagram which represents the entire data for the business. As we are here talking about OLTP. Then we will see relations are there, then how they are related to each other, and relation also can have certain attributes. Like if I am selling, then the date of sales is not the attribute of the product. Date of sales is not the information of a customer. Date of sales is not information of the branch. Then what is the information? The date of sales is the information about selling. So like this, you have relationships and their attributes. So this is how ultimately, after capturing all the information of the business, this is how your ER diagram will look. So you have to create the ER diagram, and this is how it would look. Now, once ER diagram is created, so using the ER modeling technique, then you go to the next part. What is the next part? The next part is normalization. So normalization. So going back to the recap document, let me show the recap document to you. So what I showed was the technique of modeling. So modeling, you can see here. Then you have to go to the next process of conversion. Conversion means what? You have the models, like I showed you just now using the diagrams. You have to convert them into tables. So converting, okay, entities E, okay. Then relations and attributes to tables. This conversion is a very important process of modeling. So how do you convert? So there is a process involved. So you convert usually a table, entity is converted to a table. Then the attributes become the columns. And then relations, or you can say keys. Keys means attributes which is used to identify unique information. Like I want to identify that employee, so I will use the employee ID. So that's called keys. So keys we implement using primary key or unique key. So sometimes they call it as alternate key. So or unique key, alternate key or unique key. So this is how you implement. Then this is implementation of the keys. Then how do you implement relation? So we will implement relation using your foreign key. So this is how the implementation, for implementing, I have to first convert. And this conversion is given in here. So converting entities, converting relations, converting attributes, okay, to columns. So this is how it is done. Then keys, then foreign keys. Once you have converted this into table, then how does the table look? So let us go to the next process. Table is there. Now we have to see whether the table is optimized for starting to query. So what you have to look at is how tables are optimized. I'm going to show you a small Excel sheet. And this Excel sheet explains how modeling is done or how normalization is done. 1 minute. Let me open the Excel sheet. I'm just opening an Excel sheet to show you once you have created you have converted into tables, how the table would look and how do you normalize. So this is a typical example uh, where I would be having a table. So we will start with the basic table. So I would be having a table like this, opening a new Excel table. So here, this is how a table would typically look. So we may start with one table and then we may decide to remove duplicates. So slowly you start removing duplicates. So initially that data, this is like quick and dirty solution. Quick and dirty means everything put into one table. But then using the normalization technique, which we are not studying as part of this course, we come up with many tables. So this is how the table will look. I'm using Excel to implement the table. So this is how the table would look. Typically, I have a specific table containing the order heading. That means one order, one row you will have. Then you will have order detail. So here you have order detail. And what will be there present in order detail? Then what will be present in table called books? Suppose I am selling books. So there will be a table called books. Then there will be table related to discounts. Now, how do you come to these tables? These tables you come to by the process of what is called normalization. Then you may want to include certain columns in certain table, like you may want to include the book name. Book name is in book table, but you want to include it in the discount table, book discount. So you can include it. So this is called denormalization. So quickly to put it across, which columns will be there in which tables, and what are those columns which can be duplicated across tables. These decisions are taken when you are doing normalization and denormalization. This is called low-level design. So let us go back to the steps we were looking at. And so this is the step. So we are looking at this step called normalization, denormalization. So after you create entity relationships, it will automatically, it will just give you what are the entities, etc. And then you will have to create tables out of it. Then using this normalization technique, you will try to remove duplicates and create multiple tables. And using the denormalization technique, you will actually try to bring in duplicates. So with the end of all of this, you will have a set of tables. Sorry. You will have a set of tables. Now, you need a database engine to implement the tables. And the database engine to implement the table would be SQL Server in our case. So we are now going to see SQL Server. So let's just go to the SQL Server. So now I am going to introduce you to an engine which is called the SQL Server engine. So let me share the screen. Yeah. Sorry, it was not visible. So now we come to this SQL Server engine. Now, before we get into SQL Server Engine, certain things that one needs to know is there are tools to connect to SQL Server Engine. The SQL Server Engine is nothing but a service, a database service. And this database service is installed separately after you install the operating system. So here I have Windows 11, but usually we will use server operating system. And this is installed as a separate application. So let us look at how they are connected to each other. So I'm going to get into a document called logical architecture. To connect to a SQL Server Engine, I require a tool, and the tool here we have is the what is called as SQL Server Management Studio. Now, using this tool, we will also be looking at what are the components of SQL Server. So we will go to our notepad where we have the logical architecture of SQL Server. What do you mean by logical architecture? This is the tool which is connecting to SQL Server. What are those components that are present inside SQL Server? That is called the logical architecture. So we will be looking at the logical architecture. So I'm going to share a new screen so that you look at the logical architecture. Here I do have the logical architecture. Okay, for somebody who just joined, I think we just covered what are the topics we are going to cover as part of this course, my introduction, and yesterday we started the demo session. So for the purpose of people who didn't join yesterday, I did a recap of what we did yesterday. So today we are starting with this topic of SQL Server logical architecture. Now, SQL Server is a database engine. So what all are present as part of this database engine, we will see. First, let us look at the system. System means my server, the PC in which we are storing we are going to be installing the SQL Server. That is the system. It is a server system usually. It will have a server operating system, like you have different server operating systems. Like how you have Windows 11, etc. You do have different server operating systems in place. Now, each system can have many instances of SQL Server. It's called SQL Server instances. Okay. Now, each SQL Server instance, so you can say either is a default. So you can have a default instance. Default instance means that SQL Server engine, the name of the engine will be the same as the name of the server. Or you can have the named instances. Named instance means because you can have many instances, you have to differentiate between them. So we have something called named instance of SQL Server. So what do we mean by instance? So SQL Server is a multi-instance application. What do I mean by multi-instance application? Every instance will have a process. A process means you will have an exe corresponding to it. You have a process corresponding to it. So every SQL Server instance will have a process corresponding to it. How many instances can we have in one system? Many. That depends on the SQL Server version. So you can have 32, 64. So now they are increasing the number of instances. What is the purpose of so many instances in one server? Sometimes you can have a business of hosting. I can be the person who is hosting the database for many businesses or many clients. Then what happens? I will have one instance for every client. And I will manage the database for those clients within the instance. The main purpose is what? The main purpose is one person should not have access to data of another business. So they have created instances. And in fact, that is what is being used now by Microsoft. That is what is used now by Microsoft. Microsoft has cloud platform and many SQL Server instances are there. For every business who wants to create their own set of databases, they will give one instance. So it's like one instance given to the business. Microsoft for using that instance for so many years or so many days. So that is how it is working. So you have SQL Server instance. So how many SQL Server instances can you have? You can have as many as supported by that version. How do you see the SQL Server instance? I'm going to go back. So I will now share the entire screen so that I don't have to go back and forth. So, okay. So now I go back to show you the instance. So this is the SQL Server instance. So if you have installed SQL Server in your system, you will notice that this is the instance that we talk about. Using the SQL Server Management Studio, I will connect to the instance. And can I have multiple instances? We have just seen we can have multiple instances. This is called as the default instance of SQL Server because the name of the instance, so here the name is Brahmamayam. The name of the instance is the same as the name of my machine. So the machine which I am installed the SQL Server in is the same name. Therefore, you have this instance. This is the SQL Server instance. Within the instance, now let us see what else do we have. Within each SQL Server instance, which is either default or named. Ours is a default instance. So you can also have your own names, the named instances. You can have many server objects. So what are the server objects you can see here? It is database, security. Then you have certain specific server objects. Then you have replication, polybase. All of this is part of this instance. And this instance is referred to by server. You should not think, how did server come suddenly? Every instance is referred to as a server. Server instance. So you have default server instance of SQL Server. And it has many server objects. So let us look at server objects. One of the server object is your database. Now, every database can have multiple database objects. Now, before that, what are the different types of databases? That is important, like how you have instances, default and named. Different types of databases are there. They are categorized as system database and user database. So let us look at the example of system database. What is the purpose of system database? Purpose of system database is to store data about the data. Like how many databases are we going to create in our business? That information will be present in the system database. How many users are going to be accessing? That will be present in system databases. In this manner, we have 4 important system databases. They are not created by the user. They are created by SQL Server when you install SQL Server in a system. And SQL Server will keep track of these databases. We are just going to see what is the importance of each system database. So let us look at the first database called MasterDB. Whenever you install one instance of SQL Server, all the important information about how many databases are created for the user in this server or in this instance, all the columns, the information about the files, all that information about a database. Like for example, I have a database called AdventureWorks. So what are the files? Because internally it would be storing the data into files. So all that information will be present in MasterDB. What is the database? What are the files in which the data is being stored will be present in MasterDB. It is very important that MasterDB should always be available. Why? Because if their MasterDB is not available, then the data about what are the other databases will not be available. That is why what they do is they take a backup of MasterDB and latest backup would be available. This is your master database. So this is the first system database. It stores data about other databases. And it is important to backup. You should have the latest backup. Then you have ModelDB. ModelDB is mainly used when you are creating a new database. So you can create your own new database. We will see how to do that later. And when you're creating that database, you require this database called ModelDB. All of you would have worked with Microsoft Word. In Microsoft Word, we are having templates. Using the template, a user can create a new document. Similarly, using this ModelDB, whenever we want to create a new database, there will be certain system tables, certain tables which are created not by the user, by SQL itself. All those tables will be present in ModelDB. So ModelDB is like your template. Okay. Now, using this template, system table is not visible, but it is present. We will see as we proceed further. So using this template, new databases are created. Then you come to the next system database called MSDB. MSDB system database is mainly meant to store information which are administrative in nature, like who are the users who can access this database. Then what are the jobs that are created in the database? Some jobs will be created, like I want to back up the database every 1 hour. So some jobs will be created. And those jobs information will also be stored in MSDB. So this is your MSDB database. Then we have the TempDB database. The TempDB database is going to be used as a scratchpad area. What is the purpose of TempDB database is, suppose I am writing a query to get the data or extract the data from SQL Server. Then you require memory to implement the query and get the data. So the memory will be present in TempDB database. So TempDB database becomes the database which stores information, right, when it is processing a query or processing any statement which is made to SQL Server. Like you will tell SQL Server, get me all the accounts for a particular branch. Then SQL Server has to implement it by going to the file, picking up the data, etc. And when it is doing that, if enough memory or RAM is not available, it will store the temporary result in your TempDB database. That's why it's called TempDB. We can also create some tables, etc. here for our own purpose in TempDB. But it will be deleted. And every time you restart the server, server means the SQL Server instance, TempDB will be recreated. So let me summarize the purpose of the 4 system databases. System databases are meant for storing system information about SQL Server. First is master database, which stores information about all other databases. Model database, which is used as template while creating new databases. MSDB database, which is used as a container to store information about administrative jobs and users. So that is the purpose of MSDB. Then TempDB acts as a scratchpad area. If when SQL Server is processing, if enough memory is not available, it will use TempDB to store the data. And we can also use to store temporary data in TempDB. We'll see how by creating temp tables. So this is called as a system database. So let's go back to the logical architecture. So if you see the server object, you have databases. And databases can actually be user database or system database. So we say system database or user. Now let us look at the user database, because I have just defined what is a system database in brief. Let us look at the user database. So the user database is created by the user typically. Like I would be creating a database here by saying new database. I can use the user interface to create, or I can use code to create. We are going to see both. So I will be using the user interface here to create the database, and I say test and I say OK. So it creates, you can see I created a test database. It is created. It is a user database. Information about this database will go and sit into the master database. So this is how the system works. So every server or every instance will have system database, and as you create, you will be able to see user databases. So going back to the logical architecture, okay, one server or instance can have many databases, mainly system and user databases. Now, every user database or system database can have multiple database objects. But right now, we are not going through system databases. We are going to see if I create a database, and in that database, I can have many so-called database objects. And database objects are like, for example, tables. So I have given some example here, tables. So you can have user table, you can have system table. So we are looking at, or we are more interested in user table. Then what does system table store? Systems table store information like name of the tables you create inside the database, columns, etc. That will be stored in the system table. And the user table will store the user information. So let us go back and see here. This is one of the user databases called AdventureWorks. And in AdventureWorks, you can see there are tables. So he has divided it into system and other tables. The system table will not be visible through the user interface. It should not be, because it's not meant for playing around with. It is an important table showing storing metadata, data about other tables. So they should not be tampered with. So I have this AdventureWorks system table, and then I have user table. So you can see these are the user tables. Now every user table will have columns, etc. But what is the important thing to note? Every table will have two parts. The first part is called the schema. What is schema, etc. will come to it later. But this is just for us to get oriented towards what it means. So what you see here is the schema. And then the second part of the table name or whatever it is, the second part is the name of the table. So schema and the name of the table. And suppose I have created a table default. There is something called default schema. So here DBO is the default schema. So I have the schema. Schema is like logical container. It can contain tables. So this is your schema here. Purpose is mainly security. So you have multiple schemas you can see. You can create your own tables with your own schemas. So this is how you have the user database, and the user database will have multiple system tables and user tables. User tables don't have a separate folder like what you see here. System tables has a folder. So this is the next part. So every user database will have multiple database objects, and database objects means user table and system table. Okay. Now, where will the data be stored? So that is what we have to see now. Okay, I have some data here. You will see in the tables. Where is this data in the tables stored? So I will have this data. From where does it come? So we have already seen. So people come up with entity relationship model, then create tables out of it. Here you implement those tables. But where will the data go into, or the data that is stored in the table, where is it actually going to? For that, we have to understand the architecture of SQL Server further. Okay. So that we will do in tomorrow's class. So today I would like to recollect what we have done so far. So we have seen SQL Server is installed in a server operating system. And in each server, you can have many instances of SQL Server. Each instance of SQL Server can have many server objects. One of the server object is database. Each database can have many database objects. But databases are of two kinds, system and user. System databases are master, model, MSDB, and TempDB. These are the only 4 system databases. User cannot create system databases. It is automatically created when you install SQL Server. Then these are your user databases, right? And the data inside the system or the user database goes and sits into a file. How does it sit into the file, etc.? We will see the details tomorrow. So with this, today's class I conclude. And I am going to be presenting a small URL. Yesterday also I had presented. And that URL is for the purpose of filling in student information. And this is important so that we can get back to you. If you want to continue with this SQL Server session, we can get back to you. I'm going to post that URL. Please fill in the student information form so that from our side, people can get back to you. You can ask them any information you want about the training. And this training will be, for now, it is decided 8:30 to 9:30. So you can, when you are inquiring, you can give your suggested timings. The session will be recorded. Every session will be recorded. And this is the second demo session that we had. So between us, so please do fill in this form whenever for the purpose of, it is like showing interest in this training. So with this, I complete. Is there any question? I have 2 participants, namely, I think Mohammed is there and Madhu. Madhu and Mohammed both had attended yesterday. So yesterday's recording was not there. Therefore, I recapped what we did yesterday and then we continued today. Okay. So any